Hello guys and welcome back. So let's take a look at what we have now. So far we've created these two sources. We have the outbound, the bounding box working, and everything is coming from a cached file. Now it's a little bit slow, just tiny bit slow, but that's because the data is quite heavy, and maybe I should have gone with something a little bit more low res in this case for faster interactivity, but it's fine. I'm going to use it as it is. So I have this setup, which is basically what we've created previously under the gas field VOP. I have pretty much the same from last week that we started with, and I'm going to use it for this week as well. The other thing I'm doing is I'm taking the length and computing the length of this temp velocity that we're injecting. I'm computing the length of that and then fitting it between 0 and 100, and that's what I'm using for the for my divergence. Whenever I have any turbulence or any new velocity, I compute the length of that and then inject that into the divergence just to have something. So we have advection for these fields, and then we're injecting the temp velocity, we're injecting the div temp into the temperature as well, and then the div temp into the divergence. Both of these guys are being injected into the temperature and divergence. And let's see, and then this is a clamp for the temperature between 0 and 1000, just in case it exploded, and then we don't have anything for sourcing. So I'm going to use a volume source, and I will share this HIP file if you guys wanted to start from the same starting point. So for the source, I'm going to source smoke, obviously, and export relative, so out density. Cool. Let me turn off the fire display, so we just have density, and let me multiply this by 10 so we have something to look at a little bit more visible, and let's hit play. Cool. So far we have a lot of smoke coming up. I don't want any velocity, so I just set this to 0 just to make sure I don't inherit anything, and it looks like the source itself has a velocity. And the main thing that I'm looking for is having a sim where I don't have to increase the substep a lot. Actually, I do have it here, so let me turn these guys off, and let's set this to 1, and I'll explain what that is. So right now it's set to 1, and voila, we have our continuous tendrils emitting, and you can see how fine they get without having to increase any substeps or anything. And this is relatively fast moving object. We can go faster, and in that case, if the object is traveling really fast, we just have to make the trails a little bit longer so that the sim have some time to pick up that information and inject it in. Now look at how nice those breaking are happening. Look at the details we're getting here. Now obviously some stuff is going to start expanding and probably going up, but overall we're capturing all the details from within the sim, and independently from how much we have, we can increase this up to 1000, and we can go even finer if we want to, and we'll still have pretty much the same overall speed of the sim, except the overhead of the actual voxels being added. But let's take a look. This is still not very high res. Let me increase this to 0.7, and let's cache the sim interactively. I just want to show the details here, and then we'll import it and make sure that we're viewing it at 1024 or higher in the visualize node. Let's see. And remember, we're not having any substeps or anything, so that's another huge factor. Now what you guys saw previously is I've had the substeps animated to start at 4 and then go down to frame to 1 at frame 20, and just that to give it more room just in case we need more details in the sourcing. I believe the first source that I had was moving much faster, and so I had to do that. The other thing is, most of the time it's much better or much easier to do the sim with a reasonable with the source moving at a reasonable speed, and then speed that as a post process, basically using a time warp, speed the beginning 40 frames by 4, so you have 10 frames. It's better to do that versus having to deal with a crazy moving crazy fast moving object that you have to solve all its information in 10 frames, and you have to increase the sub steps and everything. It's much better to do it to take your time in the beginning and then speed it up as a post process. I do this a lot, especially with these object that takes a lot of time to emit smoke and things like that. So let's take a look here. You can see 20 frames. It didn't take that much to solve, so it's imported up fields. Cool, and let's use a visualize node. Cool. Let's increase this, and I don't think I have. Do I have any lights in the scene? Cool. So we have some lights in the scene. Let's set this to 1. And there you go. You can see we have a lot of fine details in the sim. Obviously, if you're planning to do close-ups or anything like that, you may have to go higher. But overall, this is looking very, very promising. And again, we're capturing a lot of details here. So in the next video, we're going to continue playing with the sim and trying to get something that looks more like an actual explosion. Thank you for watching, and see you in the next one. Bye-bye.